Hey, welcome back to RamZland. Today I want to show you how to detect radiation levels from some samples of uranium-238 with my digital Geiger counter. Check this out. All I'm using in this investigation is my digital Geiger counter and some samples of uranium-238. Okay, so I've turned on my Geiger counter and I can hear it clicking and it says CPM 17. CPM stands for counts per minute, and that's measuring radiation in the background. So anything between like 0 on up to 50 CPM is pretty normal background radiation. So what I want to see is what happens when we get our Geiger counter close to uranium-238 as it emits alpha radiation and decays into thorium-234. What will happen to my Geiger counter? Let's find out. So even when handling low-level radiation like uranium-238, you really should wear gloves. And this is what our sample of uranium looks like that's being shielded in this aluminum can. Let's get our Geiger counter and take a look at where it is right now. It's at 19 CPM. Let's get it closer to our uranium-238 and see if it gets any higher. Up to 20. And again, that uranium-238 is emitting primarily alpha particles, which is really the same as a helium nuclei, helium-4, with 2 protons and 2 neutrons. And slowly that uranium-238 decays into thorium-234. You can see our CPM is up to about 31, 32 maybe. But definitely this is low-level alpha radiation that's coming off of this example of uranium ore. Up to 33 now. And again, you want to store this in aluminum or lead. Okay, now these next samples of uranium-238 are stored in lead, and that's because they give off more radiation. So right now, we're at about a CPM of 19. And let's see how that increases. I'm going to take this sample out and see what it looks like. Slowly increasing. Up to 46. Now if this gets over 100, we're going to put it back in the lead and shield it and see what that does to our Geiger counter. It should go right back down again. So again, you can see the uranium that's in this glass vial. We're up to 70 and slowly climbing. And again, this is mostly alpha radiation coming off of uranium-238. It's detecting a little more radiation, up to 90. When it gets up to 100, it'll start beeping. And that's kind of a warning that it needs to be shielded. And let's see if it gets up to 100. Pretty close, but not quite. So we're going to put it back in the lead, and then we're going to shield it so it's completely covered in a lead cylinder. Now we're going to watch that CPM, that count. See, it's going down now, and again, that's because it's shielded. So now it's down to 71. So you can really see the effect of lead shielding. Very effective at shielding those alpha particles, or really any kind of radiation. You can see it dropping very quickly now, down to 54, 50. But again, any amount of uranium, even if it's in glass, I would definitely wear gloves. The these ore samples. But that's the effect of shielding. You know, lead is very effective at shielding. It's down to 20 now. And I think we're up to 80. So very effective. So what we looked at today was the depleted isotope of uranium, uranium-238. So it's not used for nuclear fission or nuclear bombs. It gives off low levels of alpha radiation. It has a half-life of 4.5 billion years. Uranium was first discovered by Martin Klaproth. He was a German scientist in 1789. But uranium-238 does have some uses since it's such a dense metal. It is used to jacket projectiles for armor-piercing weapons. I hope you enjoyed today's edition of RamZland, and I'll see you next time. If you enjoyed this presentation, be sure to remember to like and subscribe.